Well, thank you everyone for joining us today. If you are not already, please, if you haven't already, please go ahead and mute your microphone. And we're going to get started. We are delighted to have you as a part of the event today, the Virtual Foundries webinar, Radiation Shielding with Rapid 3D Shield Tungsten Filament. This is an exciting product that is really gaining some traction in the marketplace. So it's a great time to talk with you directly about what this material is doing for others and how you can use it as well. Today is Tuesday, April 16th, 2024. The time is 11:03 a.m. and the temperature is 61 degrees Fahrenheit. That's 16 degrees for you Celsius users. It's a little cooler today here in southern Wisconsin, but we've been enjoying some summer-like weather the last couple of days. Everyone's been outside as much as they possibly can be, soaking up that sun. Your presenters today are Brad Woods, our founder, inventor, and all-around science guy. Say hello, Brad.
Hi, everybody.
I'm Tricia Cease, president of the Virtual Foundry, and behind the scenes helping manage the call today is Austin Triggs, who wears quite a few hats around the Virtual Foundry. If you've emailed us with a question, it's quite likely that you got an answer from Austin. He'll be posting resources in the chat as we go today. Give us a hello, Austin.
Hi, everyone.
The webinar is being recorded and the recording will be posted on YouTube within the next few days. And you'll receive an email when that video replay is ready. Now, we do have Q&A time set aside at the end of the session today, but type any questions that come up into the chat box. Sometimes we can answer those questions as we go. In your webinar registration form, a couple of you mentioned being interested in networking with others using Rapid 3D Shield Tungsten Filament for radiation shielding purposes. It's a very interesting material, and we always encourage our partner innovators to talk with each other about the materials and what they're working on. So one way to do that is in the Virtual Foundries Discord server. Austin, please post a link to the Discord. So he's already done it, so he's ahead of me. And then I will also send a link to that Discord server in your follow-up email. You can also send me an email at info@thevirtualfoundry.com to let me know that you're interested in networking with others. You can also just type the word networking in the chat box and include your email address, and we will make sure that you get connected with others using the material. Now, let's take a look at today's agenda. First, we're going to talk about FFF metal. That's metal 3D printing that you do on a regular 3D printer. We'll talk through the basics of that so you get the scope of the Virtual Foundry's metal 3D printing system in general. And then we'll really focus in on that Rapid 3D Shield Tungsten Filament, its properties, applications. What about some different variations of that filament? We'll show you a couple of ways to get started with 3D printing Rapid 3D Shield Tungsten Filament. Again, that Q&A section there towards the end, but please ask your questions as we go in that chat box. And then we'll give you a little bit more information and resources to help you get started. So let's get into it. Now, all of our filament materials, metal, glass, and ceramic included, are made in generally the same way. We start with a loading material of metal, glass, or ceramic, and we put as much of that as we can into a PLA binder. Because the powders are held together by PLA, they print just like PLA. So from there, typically the parts are debound with heat and then sintered again with just heat. Most stock filament materials complete the debind and sinter processes in open atmosphere with no gas or vacuum needed. The two current exceptions to that are aluminum and titanium, which do require specialized environments. And then once sintered, you can do anything to that final part that you would do to any other piece of metal, glass, or ceramic. That includes welding, brazing, machining, etc. The parts are microscopically porous, which is a property of powder sintering. So that is the basic 3-step process that most of our materials go through. The tungsten filament is going to be a little bit different, as you'll see as we go through the webinar today. But as far as printing goes, that's going to be just like all our other materials, and we'll talk more about that. So about Rapid 3D Shield Tungsten Filament itself. Vulcan Global Manufacturing Solutions is located in Milwaukee, Wisconsin. They're just about an hour and a half away from us. And they're a lead products manufacturer. They wanted a 3D printable radiation shielding, and they heard what Brad was up to here at the Virtual Foundry, and they reached out to him. Well, it's not practical to make a lead 3D printing filament. So they commissioned with Brad a tungsten version of our current FFF metal 3D printing filaments. From there, Vulcan secured the patent for a 3D printing method for producing tungsten-based shielding parts. There's a graphic of the patent there. It's number 9992917B2 if you wanted to look that up. That patent was issued in June of 2018. From that point then, Vulcan GMS and the Virtual Foundry formed a joint venture to create a company called Rapid 3D Shield, which is responsible for Rapid 3D Shield Tungsten Filament. So we use the words Rapid 3D Shield a lot, meaning the joint venture company and also the material itself. Now, Rapid 3D Shield does have its own website, www.rapid3dshield.com. So when you go to that website, you'll see both the names of Vulcan Global Manufacturing Solutions and the Virtual Foundry. Brad, would you like to add anything to that story? I know that's a favorite of yours.
Yeah, that's kind of a fun one. That was one of the first materials that we did, and it was the first custom material that we did for an outside organization, and I wasn't quite sure how to handle it. So the CEO and the owner of Rapid 3D Shield, Chuck Yonke, I was kind of hiding from him a little bit, and then he tracked me down at a trade show, walked up in front of me and held up his card, and didn't say any words at all. It was hilarious, but it turned out to be a really good a good team between the two different companies.
Yes, it's been a terrific partnership. Now, getting into some of the properties of Rapid 3D Shield Tungsten Filament. Now, because the Virtual Foundry's metal filaments use a PLA-based binder, they print just like PLA. If you're already printing PLA, the switch to metal filaments is a breeze. And Rapid 3D Shield Tungsten Filament is no exception. In fact, it's one of our easiest materials to print, surprisingly, along with being the most dense 3D printing filament that we make. You'll use a 0.6 millimeter hardened steel nozzle, select the generic PLA profile in your slicer, change your nozzle temp to 210, and the flow rate to 135%. Now, lots of our materials ask you to use a FilaWarmer, which is a warming device that eases the path from spool to printer. You will not use one of those with Rapid 3D Shield Tungsten Filament, so that piece of equipment is not required. That's it. You're printing radiation shields on your regular 3D printer, like your Creality, your Bamboo Lab, your Raise 3D, or your Ultimaker, and many other 3D printer brands. Now, these instructions are all listed on our website. So if you didn't catch what I was saying in line there, you've got them listed on the screen, and they're all on our website. On the website, you'll start with the how-to tab, and there's a printing page listed under that. Now, the properties of the Rapid 3D Shield Tungsten Filament, you'll see some of those listed here. these properties or these tests were performed on printed tungsten parts. They're also reported on a printed green part, so no debinding or sintering activity has been performed on these parts. Now, due to parameter settings or changes in the methods used between printers, these specifications can't be guaranteed on printed parts that you make yourself, but we do have a test that you can perform to make sure your print settings are optimized and you're getting the most out of your filament. So if you were taking in that data on the prior screen, all of that is listed on the rapid3dshield.com website. So you'll see all of those listed there. The link to the model, Austin has already posted the link to the model in the chat box, and it will also be sent in your follow-up email, and it'll be included in the video description once this video is posted to YouTube. But you'll print this model to make sure that you're getting the highest density that you can out of the material into your print. So when you print this model, then your final part should weigh 5.5 grams or more. And then you'll know that your print settings are optimized to get the most density from the filament possible. Now, how about those results? Now, what you're seeing here is an X-ray test up to 180 kilovolts. The top and middle rows are machined lead in the step test shape you see in the upper left corner of the screen there. The bottom row is that same shape 3D printed in our Rapid 3D Shield Tungsten Filament. Now we do have data that goes up to 450 kilovolts, although it's not formatted nicely as this graphic. I'll show you that on the next slide. But in the meantime, I did want to show you what that step test looks like. So I've got one here. It's about 6 inches wide, and then at the thickest part, or at the thickest part of it, it's a 1/2 inch tall, and then it's got graded steps down. So the drawing for the piece is in the upper left corner of the screen there, and then the final part looks like this. This is that 450 kilovolt test result. It's using the same test shape. So looking from left to right, the leftmost image is 3D printed Rapid 3D Shield Tungsten Filament. The next image is that same machined lead. The next, the blank space is actually not blank. It's that same shape, but 3D printed with our copper filament. That material was also included in these tests. The last image on the right, then again, is lead. So we know a lot about making these types of filaments, and we know only a little bit about radiation itself. So while it's clear to see how the tungsten compares to lead, we don't know what the yellow numbers on this image mean, and we really don't know more about the results. Like, we can't explain the results to you really any further than what we see on the image. Additionally, X-rays were the only type of radiation that's been officially tested by the Rapid 3D Shield company itself. Now, the Universidad La Frontera recently published a paper. It's called Characterization of Radiation Shielding Capabilities of High Concentration PLA Tungsten Composite for 3D Printing of Radiation Therapy Collimators. That was authored by Jose Velasquez, Melanie Fuentealba, and Mauricio Santabanez. And my apologies for my terrible pronunciations of those names. Austin has put a link to the paper in the chat. Again, that will be included in the follow-up email as well.
And this paper focuses on photons in a linear accelerator. So this is a very different type of radiation and could likely be useful to some of you.
Great, thank you, Brad. And the paper is very robust in describing the shapes that it used, the intensities of radiation that it used, and the results. And the statement that you see on the slide there is one of the conclusions in the paper. So testing parameters, results, some positive conclusions, and yes, it will give you much more data and information than we're able to interpret for you here. So be sure to take a look at that paper for those additional, for that additional information. So how do you actually use the material? We talked about those print parameters earlier. You'll find those full details on the print page of the website. And you also, in the opening of today's session, learned about the 3-step print, debind, sinter process that applies to most of our materials. But I say most because a rapid 3D shield tungsten filament does not need to go through those debind and sinter processes to do its radiation shielding job. Excuse me. Now, no sintering trials have been conducted on the material. Tungsten has a super high sintering temperature, about 2200 C, which is nearly 4000 degrees Fahrenheit. So the fact that you don't need to go through that debind and sinter process is really helpful. The La Frontera paper also does make some comments about how the fact that the PLA binder is still in there really doesn't affect the usability of the shape of the material. So they do comment on that part as well. But what if you did want sintered tungsten? There are a couple of options here. Brad, please talk to us about the pre-alloyed filament or printing two different materials together to achieve sintered tungsten.
Yeah, we're working on a few versions of this. So some of them will be like a tungsten boron pre-alloy or something like that. The other option is liquid phase sintering, where you'll use exactly the same tungsten, but you infuse it with a material that melts at a lower melting point. And I've done this in experiments with bronze, so we will wind up with essentially tungsten particles bound together by bronze. So there are options here, though most of them, well, all of them at this point would require some development. In time, the Virtual Foundry will release a sinterable version of some type of a tungsten alloy.
So to that end, we would like to know what would be useful for you. So in the chat, tell us your thoughts, or you can also email info@thevirtualfoundry.com. In the chat, tell us your thoughts on the 3 questions on the right. What do you see as potential applications for sintered tungsten? What would be the properties that are most important to you in a product like this? And what are some of the biggest challenges with working with traditional fabrication as you think about working with tungsten in the way that you had been making tungsten parts either currently or before you started using Rapid 3D Shield? Because I know there are a few folks on the call here who are already using the material. Your responses will help us with a direction for moving forward with a sinterable tungsten option. And if sintered tungsten doesn't matter to you, if you're using the material and it's working awesome for you, you don't care about having sintered tungsten, that would be helpful for us to know too. If this isn't a great need, that also helps us know how to move forward with it. So some of the applications for Rapid 3D Shield, obviously, radiation shielding is a big one. It has shield right in the name, right? But also anything where density is needed, counterweights, anti-vibration munitions, frangible projectiles, nuclear power plant safety accessories, and a couple of other cases. A university is using the material for radiation oncology research. A laboratory did research on conformal and custom radiation shielding composites for human extremity protection for radiation workers working in glove boxes. And a professor at a university who teaches nuclear pharmacy, they frequently use tungsten as a shielding material for the medicines that they're working with in that classroom environment. So there are some of you that have worked with the material already. If you are open to it, you can come on the call and let us know how you're using it, how you've used it in the past, or add some notes in the chat. So as we learn about more of this, okay, so Bruce Power has been using Rapid 3D Shield. And then Michael, can you tell us a little bit? Are you able to tell us more about your specific use?
Yes, can you hear me?
Yes.
Hi, good morning. So I'm a health physicist at Bruce Power. We initially, well, we use it for a custom solution as opposed to using our lead blankets are 1 foot by 3 foot, and they're about 33 pounds each. So instead of using, let's say, 3 lead blankets at 100 pounds on something, we can replace it with our shielding designs are roughly like oval pill shaped things, maybe 2 to 4 centimeters thick, between, I don't know, half a kilogram to, I think the biggest one we've printed so far is about almost 4 kilograms. And we're seeing shielding reductions in the shielding about 90%. So we obviously we base all our calculations on cobalt 60, but we've seen, I think the best we ever saw was about 140 rem per hour down to about 7. So it worked very well. Obviously it wasn't cobalt 60 there, but we're not going to argue with the results. We've had pretty good success with it. We're applying it everywhere. You could say we're in full production right now, using it to put it in. We have 8 units running, so there's many places that we can take advantage of this material.
Great. Thank you very much for those comments, Michael. We appreciate hearing that. Our partners in the Department of Defense also use this material, but we can never know what they're doing. So it's good to hear from somebody directly who's using the material. So we appreciate that. Thank you. Now, Michael mentioned making prints that are up to 4 kilograms, and I appreciate the segue into being able to tell you that we can, while typically our material is sold by that half or full kilogram, we are able to load this tungsten filament heavier onto a spool. So standardized now are 3 kilogram spools and 5 kilogram spools. We can explore something larger than that, but just keep in mind as you're thinking about a spool with more material on it, is that the axle that the spool will need to spin on as it feeds the 3D printer. We want to make sure that that can hold the weight. But we do have 3 kilogram and 5 kilogram spools as a standard, as well as 1 kilogram, half a kilogram, and then we also offer a 100 kilogram sample if you want to just try it out in your use. So check out the Rapid 3D Shield website, order some material. I talked about those sample units all the way up to 5 kilograms on 1 spool. And check out that La Frontera paper as well. Write to us at info@thevirtualfoundry.com, or even give us a call. Our phone number is listed there as well. And be sure to let me know if you want to talk to others who are using the material, and I will be happy to connect you. So do we have any questions about anything that we covered today?
This is Andy Rutledge, also with Bruce Power. Can you hear me?
Yes.
Yes.
Excellent. One of our questions, we're limited somewhat in where we can use this due to actual temperatures, because of course this softens at, what is it? I forget what it's listed as, 65 degrees Celsius or something like that.
Yes, because of that PLA binder.
Because of the PLA factor, yeah. So I know that there is tungsten in PETG elsewhere at a much reduced density. So I understand it's not apples to apples, but we would find greater use if it was able to withstand a little bit more temperature. A PETG or an ASA or something like that would be. It would just allow us to. Let's put it this way: we'd buy more material if we could use it more. So that's one of the things I'd like to urge, is to for you to either look into that, or if you already have, then to let us know where that is. Thanks.
Yeah, this is the topic that comes up pretty frequently, and we've been working on some type of a higher temperature solution. We don't have anything to roll out yet, but we're getting closer in development.
Thank you for those comments, Andy. That is something that others have talked about with us. It's definitely on the development list. Well, Brad, I do have one more very important question for you before we wrap up the call today.
Okay.
Why don't Bruce Banner's pants rip when he transforms into the Hulk?
I can't imagine.
Because the radiation altered his genes.
Nice.
So the last slide that we have for you today is just a list of our resources. These are easy to find. Some of these will be in the follow-up email that I send to you once the webinar is ready and posted on YouTube. And please always reach out to us, info@thevirtualfoundry.com, or give us a call. We love talking with you. We love knowing what you're up to, what's on your 3D printing wish list. So always let us know about that too. Thank you for joining us, everybody, today. It was great to have you with us.
Thanks, everybody.